Okay, so what I'm going to do is I'm going to start off and share with you some thoughts about deploying applications. And I'm going to use a lot of the information that I've learned through all the cloud camps that we've done. So in a way, this is kind of a summary of what we've learned. So basically, there's quite a few slides here, but I'm going to do a quick introduction. I'm going to talk about different ways you can deploy applications. I'm going to talk about the evolution of scripting, and then what's next. And the what's next part will be much of a conversation. Okay. So first of all, I've been doing internet stuff since the 90s. I was very early as a programmer on the web. I got involved in web APIs very, very early in the late 1990s, and mostly through e-commerce. Eventually, I was hired by PayPal to be their API evangelist. I was one of the first to do that. I went to a startup called StrikeIron, which was an API marketplace. In fact, StrikeIron was so early to the API market that Amazon came and talked to us and said, we have a patent for an API marketplace and you need to shut your business down. And we said, we launched our business before Amazon filed their patent. So we were able to invalidate Amazon's patent for an API marketplace. So we were very early. I got involved in cloud computing because of my experience with web APIs. That was a kind of a natural extension. We started Cloud Camp in June of 2008. We put on about 350 cloud camps plus another 50 or so other camps like Big Data Camp in over 100 cities. And the other camps we do like our DevOps Camp or Ops Camp or Big Data Camp. And right now I'm working as an evangelist. But what I want to talk about are deployment options. Okay? So in order to talk about deployment options, I first have to talk a little bit about cloud computing. So what is cloud computing? I'm going to take, this can be very short, but I want to do this as a way to level set, make sure we're all on the same page. Okay? So cloud computing was around in the 90s. We just didn't call it cloud computing. We called it software as a service. We called it web APIs. We didn't use the term cloud computing because we didn't need to. We used the term software as a service. We used the term web APIs. That's what we did. Okay, and then what happened is around 2006, two new forms of cloud computing were created. One is called, we now called platform as a service, and the other one we call infrastructure as a service. And what made these so different is that you could take your own code, put it in the platform as a service or in the infrastructure as a service, and now offer your own software as a service to other people. Whereas prior to 2006, there was no cloud computing solution to enable you to do that. Instead, you had to use traditional web hosting, which meant you had to buy your own servers and set up your own servers and manage all of that yourself. So, what was so exciting about it is that if you wanted to make a startup, prior to cloud computing, this is what would happen. You would go to a VC, a venture capitalist, and you would say, I've got this great idea. And they would say, if it's a really great idea, you're going to have lots of customers. And you say, of course I'm going to have lots of customers. So on your launch day, you had to have lots of servers. Because the worst thing is to launch your startup and you don't have enough servers and your website crashes and nobody comes back again. So, because you told the venture capitalists that you were going to be really successful, you had to spend a large amount of your investment money on setting up servers. Right? Can you imagine going to a VC and saying, please VC, give me $5 million, and oh, by the way, I'm only going to spend $10,000 on servers. They're going to say, wait a minute, you're betting that you're going to fail. Give me my money back, right? So the irony here is only about 1 in 10 or less startups actually succeed. That means that for every 10 startups that spend a lot of money on all those servers, only one of them actually uses all of those servers. So therefore, 9 out of 10 are wasting all those servers. Okay? So, when cloud computing came about, and you didn't have to buy all those servers ahead of time, you could simply put your code up on 1 or 2 servers and see what happens. The startups really like this. And by the way, the VCs really like this too. Okay, so that's why cloud computing took off in the startup space first. All right? And there were 2 models. There was platform as a service, and there was infrastructure as a service. And the infrastructure as a service ended up being more popular because it gave you more choice of flexibility. Okay? Now, I call it sort of cloud computing 2.0. I think it's a terrible name. I wouldn't recommend you go tell people it's cloud computing 2.0. But it kind of is, because we call it cloud computing, but there's always this confusion about when cloud they were kind of cloud computing, but they weren't cloud computing. Now, in 2010, OpenStack was announced, and so now you can do cloud computing with open source software for yourself. So that's a whole new thing. So that's kind of your history and what it's like. Looking back, once we understood what cloud computing is, looking back, we recognized, oh, software as a service is cloud computing. We just didn't call it that. It's a different type of cloud computing, but it's a type. So at this point, cloud computing is inevitable. It is unstoppable. We just don't know how much. Right now, there's a lot of people who believe there's more money in private cloud than there is public cloud. Surprise, surprise. So there's a lot of opportunity yet to come. So why is cloud computing so unstoppable? This is the terms that we came up with at Cloud Camp. Okay, so this is the Cloud Camp unstoppable characteristics of cloud computing. But basically what it comes down to is that cloud computing is on demand. That means that to really be cloud computing, you shouldn't have to call your vendor and say, will you please go set something up for me? Will you go plug in some cables? Will you configure things for me? Okay, it should be already set up ahead of time. All right. Number 2, it should be self-service. So that once it's activated, you can add users and do all the things you need to do. Now that's kind of obvious, I think. The kind of quintessential cloud computing characteristic is that it's scalable. So we say that it has the illusion, now nothing's really infinitely scalable, but for most of your customers, they should never run out of disk space or computers or anything like that. And finally, it should be measurable. Because if somebody else is providing that service for you, then you don't know what's going on. So you have to get some data that tells you that the service you signed up for is actually happening. Okay, it might simply be the server is running. Okay, it can be very simple like that. Now, these are more or less aspirational goals. It doesn't mean that every service should be like this. It just means that if you want to remove all of the barriers from your customers so that they can easily use your service without running into hurdles, this would be a good idea. And if you provide a service that is a good product and meets these criteria, you're likely to be successful. In fact, what was interesting is we came up with these criteria about 4 or 5 years ago, and we've been looking at all the successful clouds, and every successful cloud meets this criteria. So it seems to be working. So now I'm going to get more into the point of my talk, which is how do we use cloud computing? What are we using cloud computing for? Now, HP and Intel recently sponsored a hackathon that I organized as part of Cloud Camp. So this is one of the things we did. We had the opportunity to put on an event with HP and Intel, so we did. And the topic was social good. So we got nonprofits together to share their ideas to an audience of developers and designers. And then the developers and designers could join that nonprofit's team for 2 days, and they could build an application. Okay? So for 2 days, they only had 2 days to build an application. And guess what? Did they develop those applications in the cloud? In other words, were they writing their code in the cloud? No. Oh, they were writing the code on their laptop. All cases, they were writing. Question should be: does cloud computing help us write code faster? Not really. So is cloud computing helping us develop our applications faster? Not really. What's going on really is that we like to deploy our applications using cloud computing. Cloud computing helps us deploy our applications faster. Okay, and the reason why this helps application developers is because they can write their code, deploy it quickly, and get feedback from their friends or customers. Hey, is my application working well? And they can give you feedback quickly. And then if customers like the product and it starts to get popular, you can quickly add services. So it's really about deploying quickly. That's really what cloud computing comes down to. And when you deploy your code, you don't want to have to manually do it because that slows you down. So being able to automate the deployment is very important. So a lot of cloud computing services have APIs so that tools can help deploy the code into the cloud. What are we deploying in the cloud? Okay, we're deploying applications, but applications aren't just a few lines of code. Applications are actually a stack of technologies, right? And they come in all sorts of shapes and sizes and flavors. So you might have a stack of buttermilk pancakes as your application. So how many of you heard of the lamp stack? Okay, most of you heard of the lamp stack, right? That was a stack of technologies, right? PHP, MySQL database, and using an Apache server on Linux. Does that seem like brand new technology to you? No. But it was a good stack, right? We all like the lamp stack. It's everywhere. It's kind of like, but by the way, it's not just PHP. You can also use Perl or Python. Okay, so it's a very popular stack of technologies. Of course, there's also Java, right? Java has its own stack. Now, it's not necessarily the same stack for everybody, but you stack up some technologies. You might be using your Tomcat. You might use Oracle database. You might have your Spring framework. You might have some other tools like Maven and Eclipse. So you've got another stack that you're using for your application. And of course, there's the Microsoft stack, which I just kind of skipped over here. They got the .NET framework and all that with SQL Server, Internet Information Server. That's their stack. And then Ruby came along, and Ruby didn't have like a small stack. They actually started throwing all these other technologies in there. So Ruby was like, okay, you got the Ruby language, you got the Rails framework, and then some people were using Apache, other people were using Nginx, some people were using MySQL, others were using some NoSQL database. They needed to scale their application, and Ruby wasn't all that fast, so they needed to use something like Memcache or Varnish to put additional caching layers on their application. Maybe on the client side, they had jQuery or EXTJS to provide some Ajax-like services. So the stack started getting pretty big and complicated. There were lots of technologies. And now today, like a modern consumer web application has a whole bunch of new stuff. I mean, there's lots and lots of JavaScript libraries. You got jQuery, AngularJS, Backbone. There's just so many now, I can't even list them all. So many client-side libraries that run kind of as a stack in the browser. You also have your mobile technology. So you might have like your Objective-C iPhone app. You've got Java running on Android. You've got some HTML5 technologies like Cordova that help you do hybrid mobile apps. And then all of those use APIs to talk to the server in most cases. So the technology called Node.js became popular because you can use JavaScript on the client and on the server, and it worked really well. So that's a new part of the stack now. So the stacks are getting, and if you think about it, if cloud computing is about deploying your technology in the cloud quicker, then that seems like we get better at it. But as the technologies get more complicated and diverse, it makes it more difficult to have a standard deployment technique. So now we've got tons and tons of different technologies that you have to figure out how to deploy, and it just seems to be getting more and more complicated. You might have a traditional application that you want to deploy. It could be an SAP server, for crying out loud. And that might not even use a lot of the special cloud technologies. It might just run on an infrastructure as a service with a regular, some virtual machine and a database. It can be pretty simple, actually. It needs a lot of memory, and et cetera. So that's one type of stack. And then you've got enterprise web and mobile apps, which, by the way, are usually very different than consumer web and mobile apps. And then you've got, of course, your mobile phones, like we talked about. So there's different stacks for different apps. And then to make it worse, there's different types of clouds. So not only are there different stacks, there's different types of clouds you're going to deploy them into. I think the most common type of cloud that we think about is infrastructure as a service, where you have a virtual machine, which we call the compute node. And then you've got block storage, which is where you store your application data so that if your virtual machine were to disappear, you don't lose your data. You just connect the storage to the new virtual machine when you bring it up again. And then, of course, you need a network in the cloud there. So that's kind of your basic infrastructure as a service cloud. Then you've got infrastructure as a service plus, which is the basic infrastructure as a service plus things like object storage, where you can store large files in a virtual storage system that can grow infinitely. You never run out of storage. Okay? Or you can have a database as a service, so you don't actually have to set up your own virtual machine with a database. You can simply point to an existing database running as a service, and you're in good shape. Or a message queue, so you don't have to set up your own message queue. And if you do this, if you actually go and set all of this up yourself, you're kind of building your own platform as a service. So infrastructure as a service plus is kind of going towards, so there's all these different types of clouds that you can use, which makes it even more complicated. So it would be great if there was just a stack in your code, you just push it up there and you're done. Wouldn't that be nice? Boy, that'd be nice. That'd be like ice cream. That'd be like pancakes. It'd just be so nice to just sit down and have some platform as a service. All right, now, turns out there are platform as a service out there for you that will do just that. Isn't that exciting? Aren't you excited? I'm not feeling it. All right, well, the reason why it's not that exciting is that Force.com, by the way, was originally called Apex. I was a beta developer when it first came out. And it was the first successful platform as a service. And I say successful because I think it is actually successful. Are many of you using it? Probably not. But there are many types of developers who use it. The downside with Force.com is, while it is a very nice platform as a service, it really is. All right, they learned from a lot of other startups that failed, and they did a very nice job. However, it's very proprietary. So you write your code, and you put it up there. They do all this beautiful work of scaling it, and the database scales, and it works really nice with Salesforce.com and APIs. But if it doesn't do what you need it to do, you are out of luck. Because not only will it never do that, there's nowhere else you can go to put your code. So you are locked into that vendor, and there's no way out. It's great for people who are already using Salesforce, and all they want to do is put in a little business logic to supplement their existing Salesforce account. It's awesome for that, because you don't have to set up another server. You just go get some sample code, copy and paste, make a few changes. You're done. Very nice. And they have an app exchange with it's kind of like an app store. It works to sell these applications right into Salesforce. Very, very nice. In fact, you guys have heard about the Apple App Store, right? Okay. Did you know that Salesforce used to own the trademark on App Store? Yeah, because they were so early. And Steve Jobs asked Benioff if he could use the term, and he was nice enough to let him use the term. Shocking. Wow, people playing nice. But yeah, so they were very early to this, but it's so proprietary that it wasn't quite for them. Now, on the far right over here, you've got the Google App Engine. Now, the Google App Engine was trying to learn from Salesforce's mistakes. Okay, so Salesforce with Force.com was kind of like Java, but not. So you couldn't really copy any code, put it in there, it wouldn't work. While the Python language was exactly the same, the objects that you talk to within Google App Engine, so while the basic Python code would run in other places, your application would not. Right? This made it easy for developers to learn, because if you already knew Python, you could easily create applications, but it was not open and transportable. But they've been doing a good job, and they've been reasonably successful. Heroku was probably my favorite platform as a service, because they got really smart. And they said, you know what, we're going to let you write your customize it for you so that it fits in our cloud, but that code that you wrote would run in other places too. So they did a very nice job of creating a platform as a service offering that let you write your applications. You couldn't use every type of Ruby on Rails, but I'd say like 80% of Ruby on Rails would work on Heroku. So that's a good job. That's a really good effort. And they were becoming very successful, and Salesforce knew that Force.com was perceived as being too proprietary, so they actually acquired Heroku. So Heroku was acquired by Salesforce. If you're using any of their extensions, those extensions won't run somewhere else. So it's still pretty proprietary. So you don't hear about them a lot, simply because, like, most enterprises don't want to be locked into a proprietary system. And on top of that, you can't take your existing applications and move them onto one of these products. It just won't work. Okay. Now, what would work, perhaps, someday for an enterprise is an open platform as a service, something where you write your code on one company's platform, and you can move it to another platform, or even move it into your own data center. That would be appealing to an enterprise. So, over time, we've started to see these companies. I mentioned some of them to you before. Cloud Foundry. Again, Chris Richardson had the original idea for Cloud Foundry right about the time of our first Cloud Camp. And if you're in a Java world, you take your jar file, you push it up to Cloud Foundry, and then they would take it and put it out in the cloud and manage the deployment of it for you. But you could then use that software solution on any cloud, and you could actually even run Cloud Foundry in your own data center. So it's very appealing to enterprises. Staccato is essentially kind of like a fork of Cloud Foundry, so it's kind of like a distribution that is similar to Cloud Foundry. It's software that you can run in your own data center or run up in a public cloud. And there's other. So you can run like Java applications, you can run Python applications, you can run PHP applications. Okay, they actually support multiple programming languages. But unfortunately, for the most part, they don't run existing applications. It is very difficult to take an existing application and get it to run on top of Cloud Foundry or OpenShift or any of these others, because they do have their own like data model or database model, that kind of thing. It's not so different that it's impossible. It's just not possible out of the box, and therefore it kind of loses some of its value or its power if you have to do a lot of work just to get something that's already working to run in it. Right? So, but these are good products. You should definitely look at them, see if they fit your need. But most companies can't do that. So like I said, if you have a new application, you can go build it on a proprietary PaaS solution, like I mentioned, or if you want to try to run your own. If you have an existing application and you want to deploy it, how are you going to do that? How are you going to automate the deployment of an existing application?